Everybody, welcome to another video. In today's video, we're going to be talking about the principle of inclusion exclusion. So these are two main formulas to remember in the principle of inclusion exclusion. The first formula that we have is A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. And the way this would look in a Venn diagram would be something like this. So we assume that this is A, and we assume that this is B. And so when we say A plus B, we add this portion, this common portion of both, twice. And so for that reason, we need to subtract it by A intersection B so that we're not accounting for this, because the A will include the whole thing and B will include the whole thing again, and so this is going to be added up, and so we need to subtract it because it's already included. And so that's where this formula comes from. Whereas when we have three variables, A union B union C, we do A plus B plus C minus all the intersections that we have: A intersection B, B intersection C, and A intersection C, and then we add A intersection B intersection C, because we've subtracted the intersections of these Venn diagrams, if you want to understand it that way, 3 times, so we need to add it up. It would probably be better to show you visually, which is going to be something like this. And let's assume we have another one here. So this can be A, this can be B, and this can be C. So, like we said, we're adding A, so we're including these two portions over here, and then we're adding B, so we're going to be including these portions again. So as you might see, this portion is getting added twice over here. And then when you add C, you have this portion and this portion getting added as well. And now you're going to subtract the intersections. So when you subtract A intersection B, you're going to be getting rid of this portion. And then when you do B intersection C, you're going to be getting rid of this portion. And when you do A intersection C, you're going to be getting rid of this portion. But you still will need to be accounting for this portion because you've subtracted this. And so you will need to do plus A intersection B intersection C. And so that's where this formula comes from. Excuse me. So one example that we can use to solve some of these theorems is when we're, let's say, trying to find when we're trying to find the number of positive integers not exceeding 1000 that are divisible by 7 or 11. So the way we would solve this is using this formula right here. So let's assume that A over here is the positive integers which are divisible by 7, and B is the positive integers that are divisible by 11. So the formula would look something like this. We'd have 1000 divided by 7 plus 1000 divided by 11 minus 1000 divided by 7 times 11. Since we're trying to find the intersection of A and B, so we're going to check the number of positive integers not exceeding 1000 that are divisible by both 7 and 11. And since this can lead to decimal values, we're going to be taking the floor of these values. this would result in something like 142 plus 90 minus 12, which is equal to 220. Let's use the next example. Let's assume that the number of Spanish-speaking people is equal to 1,232. The number of French-speaking people is equal to 879. And the number of people that speak Russian is equal to 114. The number of people who speak both Spanish and French is equal to 103. Number of people who speak Spanish and Russian is equal to 23. And the number of people who speak French and Russian is equal to 14. And let's assume that the union of all these sets is equal to 2092. So we're trying to find the number of people who speak everything, Spanish, French, and Russian. So we're going to use this formula that we have right over here, but instead of solving for A union B union C, we're going to be solving for A intersection B intersection C, since we're trying to find the number of people who speak all languages. So the formula would look something like this. We'd have 2092 is equal to 1232 plus 879 plus 114, and then we need to subtract all the intersections that we have, so 103 minus 23 minus 14 plus S intersection F intersection R. And this would probably be better to keep it in brackets. There you go. And once we solve this, we're going to be ending up with S intersection F intersection R is equal to 7. And so this is the way that you would solve problems like this. So these are two important formulas to remember. Moving on, the way we can represent these inclusion-exclusion formulas for, let's say, n number of terms. So we have two terms over here, A and B. We have three terms over here, A, B, and C. And we could have more than these. I mean, we could have n number of terms. So in cases like that, we have a general formula that we can use, which looks something like this. So assuming we have A1 union A2, and that goes all the way till AN. The way we would express that is the summation AI, where I is equal to 1, and it goes all the way to N. And then we subtract all the intersections that we discussed. So that would be AI intersection AJ and then we would add the triple intersections that we have. So that would look something like AI intersection AJ intersection AK. And then we do -1 to the n plus 1, which will depend on, really, this could be positive or negative depending on the number of terms that we have, times A1 intersection A2, and that goes all the way till AN. So this is a general formula that we can use for an n number of terms when we're trying to find the inclusion-exclusion formula, right? So Yeah. So let's just apply this formula for, let's say, n is equal to 4 and see how this would look. So let's assume that we have A1, A2, A3, and A4, and we're trying to find A1 union A2 union A3 union A4. So that would look something like this. So firstly, we would have to consider this summation right here when we're summing all AIs. So that would look like A1 plus A2 plus A3 plus A4. And then we look at the next part where we're subtracting all the double intersections that we have. So that would look like A1 intersection A2 minus A2 intersection A3 minus A1 intersection A4. Should have probably got an order, but that's okay. Minus A1 intersection A3 minus A2 intersection A4 do we have 3 and 4? We do not, so minus A3 intersection A4, and I'm just looking to see if I've missed anything. Got A1, A2, A3, A1, A4, A2, 3, A2, 4. Okay, this looks right. And now we're going to be adding all the triple intersections that we have. So this would be A1 intersection A2 intersection A3. And we could also have A1 intersection A3 intersection A4. And we could also have A2 intersection A3 intersection A4. And then since n is equal to 4, minus 1 to the power n plus 1 would be negative. So we do negative, and then we do all the intersections that we have. So that would be A1 intersection A2 intersection A3 intersection A4. So a way to find the number of terms that we have when we have n elements is using the formula 2 to the power n minus 1. And this will give you the number of terms. Let me just point that out. This is going to be the number of terms for n elements. So we have 4 elements here, and you could count it out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Yeah, we have 15, and so that would be 2 to the power n minus 1, so 16 minus 1 is equal to 15. So yeah, this is a simple formula that you can use. I hope I'm not missing anything over here. If I am, you guys can check it out yourselves. But that's it for this video, guys, and see you in the next one. Thank you.